Good morning, students. Today we are going to discuss about the biomolecules important disaccharide, that is a sucrose. Coming to the sucrose, its molecular formula is C12H22O11. It's a disaccharide. That means on hydrolysis it gives two monosaccharides. That's why it is to be called as a disaccharide. The two monosaccharides are alpha D glucose and beta D fructose. These two monosaccharides are combined together, that means joined together with the linkage is to be called as a glycosidic linkage, that is C1C2 glycosidic linkage, which is also called as oxide linkage, and it is a dextrorotatory compound. That means the optically active compound, it will give the plane polarized light towards the right side. That's why it is to be called as a dextrorotatory. Now here, how the linkage has to be done and why, what is the major important properties? Nothing but it is a invert sugar. It is also called as invert sugar. So why it is called as invert sugar? That property we have to learn. Let's see. Let's see the structure of a sucrose. It is a sucrose. The carbon atoms. Let's see the carbon atoms. It is the 1, C1, C2, C3, C4, C5, C6. It is a fructose. Which fructose means beta D fructose, right? Beta D fructose. It is glucose. Let's see, it is C1, C2, C3, C4, C5 and C6. It is glucose, alpha D glucose and beta D fructose, right? Now here C1 carbon of glucose and C2 carbon of fructose. Here OH group is there, here the OH is there. These two are linked by the removal of water molecule. The oxygen linkage has to be there. This is to be called as glycosidic linkage. This is the glycosidic linkage. That's why it is to be called as a C1C2 glycosidic linkage, right? C1C2 glycosidic linkage. Now this sucrose is to be called as invert sugar. It is the major question, which of the following disaccharide is the invert sugar, is a very important. What is the invert sugar means? Already we discussed that the sucrose is a dextrorotatory, right? Sucrose is dextrorotatory. That means it will rotate the plane polarized light towards the right, right? Rotates the plane polarized light towards the right. So its sign is positive. When it is on hydrolysis, it gives alpha D glucose and beta D fructose. Here the sign indicates, D plus, nothing but it is dextrorotatory, and the minus indicates, that it is a levorotatory. So dextrorotatory glucose and levorotatory fructose is to be obtained. The dextrorotatory of a glucose value is plus 52.5. That is, it rotates 52.5 degrees on the right side. The levorotatory value is minus 92.4 degrees. That is, left side is the minus 92.4. According to this, when we are mixing these two and forming the sucrose molecule, the rotatory should be the levo, because levo is greater than dextro, right? But what it is showing? It's showing plus 66.5 degrees as a dextrorotatory. Sucrose is the dextrorotatory, that is plus 66.5 degrees. So that's why instead of negative, that means levorotatory, it is showing the dextrorotatory and the complex. That's why it is to be called as invert sugar. Very important question. It is to be called as invert sugar. And also very important, the sucrose is non-reducing sugar. What is meant by reducing and non-reducing? If it reduces Tollens and failing solution, when it reduces Tollens and failing solution, means it is the C double bond of carbonyl carbon has to be present. That is only for the aldehydes, the Tollens. The failings is aldehydes and ketones can be reduces. The carbonyl group is to be present, hence that has to be reduces Tollens and failing solutions. So now, if the sucrose is the reducing sugar or not reducing, if it reduces Tollens and failing solution, that is to be called as a reducing sugar. If it not reduces Tollens and failing solution, it is to be called as a non-reducing sugar. Now the sucrose is a non-reducing sugar. Why it is to be called as a non-reducing sugar? If you see the glucose structure, it is the glucose, right? If you see the glucose structure, the CHO group, carbonyl group is to be present at the C1 carbon. If you see the fructose is a ketohexose, right? So C2 carbon, C double bond O. That means ketone has to be present at the second carbon. So C1 of aldehyde and C2 of ketone. That means in the glucose, aldehyde, which has to give the positive test for tolerance and failings, and also in the fructose, the ketone group, which has to give the positive test for failing solution. These two are involved in hydrogen bonding, right? Yeah, the hydrogen bonding is to be there. That is nothing but glycosidic linkage, but the removal of water molecule, nothing but oxide linkage, right? Glycosidic linkage. Hence, these first carbon of glucose and second carbon of fructose is not to be free. That is, those are already involved in the bonding. That reason, those are not reduced by tolerance and failing solution. That's why it is to be called as non-reducing sugar, right? So come to this glucose. Glucose is a pyranose structure and fructose is a furanose structure. What is pyranose and furanose structures is? Pyranose is a 6-membered structure. In that 5 carbon atoms and 1 oxygen atom has to be present. Furanose is the 5-membered ring in which 4 carbon atoms and 1 oxygen has to be there. It's a very, very important. Here the very important is why sucrose is to be called as invert sugar, why the sucrose is non-reducing sugar. This is the reason for why, what is the anhydrolysis sucrose is giving, what are the monosaccharides, where the linkage has to be present. The glucose and fructose are which rotatory, on combining these two, that sugar is having, that sucrose is having which rotatory. The invert sugar is means what, the reducing sugar is what are the structures of glucose and fructose, and what is the glycosidic linkage. This is the today topic. Hope you enjoyed. Thank you, and if you like it, please like, share and subscribe, and we will come to the next topic soon. Thank you.